Hello and welcome back to my Tech Farm. I have another Bambulab filament testing video, and this time they are ABS versus ASA filaments. These two materials compared to the PLA or PETG are a little bit harder for printing, so enclosed printer is highly recommended, like P1S or in my case X1 carbon, but actually we don't need a hardened steel nozzle, so maybe the P1S is even better for this material. I'm talking about the stock printers compared to the X1 carbon, which has the hardened steel nozzle with a little bit lower thermal conductivity. So even if I use the same settings, maybe in my case the layer adhesion will be a little bit weaker compared if I would print it with P1S. Let's see what is the difference between these two materials according to specifications on the website. Well, there is a slightly small difference in the price. The ASA is a little bit more expensive, but the ABS available in much more colors. The ASA is UV resistant. Mechanical properties are more or less similar. A little bit stronger is the ASA, but where I can see a little bit bigger difference is the heat deflection temperature. So for the ABS it is 87 degrees Celsius and for ASA 100 degrees Celsius. Maybe you can see on the camera too that the ABS is a little bit smaller box compared to the ASA. This is because this is the refill kit which has to be placed on the empty spool, and the ASA arrived on the spool. Specifications on the box. The print temperature between 220 and 250 degrees Celsius for the ABS, for the ASA between 240 and 270 degrees Celsius, but I will use the different settings in the Bamboo Studio. I already mentioned that this is the refill kit. There is a chip which will be readed if you place it inside the AMS. We have the chip here too, but it is not visible because it's on the spool. And it is very important to place it on the empty spool correctly. Align this groove and snap together those two parts. There is a nice video on Bambulab YouTube channel how can you do this correctly. On ASA it arrived on this spool, which can be heated up to 90 degrees Celsius, important for the drying, and we have nice scale so we can see approximately how much filament we have on the spool. Pay attention that in refill kits usually you have this sticker which you can glue to the empty spool, and then you know which filament is on it, and you even have this nice scale. Now let's check the different settings in the Bamboo Studio for the ABS filament. 270 on the nozzle, 90 on the bed, and 16 cubic millimeters per second is the flow rate. And the fan between 10 and 80%. Now this is strange because on the box we can see the recommended temperature between 220 and 250 degrees Celsius. But anyway, I'm using the different settings in Bamboo Studio. Until the bed is hot, it sticks very good. And when it cools down, it still sticks, but it is possible to remove them. And now the ASA filament. I'm changing the material on X1 carbon. And again, let's check the settings. 270 on the nozzle, 90 on the engineering plate, and 18 cubic millimeters per second. And cooling is lower between 10 and 50%. This is again a timeless video. I'm printing all test objects at once. And again, when it cools down with the FlexStick, I can remove the objects. Interesting that the supports was very easy to remove. And I start with mechanical testing. These test objects are printed in horizontal position. And I'm starting with ABS. And this is now ASA. The break load was very similar, but I don't like that it didn't break on smallest cross-section area. Anyway, let's start with the layer adhesion. These test objects are printed in vertical position. And this is very good layer adhesion, even for the ABS. And now ASA. This is again very good layer adhesion. And only one broke a little bit differently. And this is a two-sided shear stress. Here you can see side by side ABS and ASA. And the break load was very similar. And they were shared correctly in 3 pieces on 2 cross-section areas. 3-point bending test, and here you can see all loads placed, but they will be placed one by one, and I'm measuring the deformation after 130 and 60 seconds under one load. And this is a timeless speed up video. At the beginning very similar deformations, but later the ASA had a little bit bigger deformation. I will show you everything in the results part. And I can see some minimal permanent deformation on both test objects. And now the torque or twist test, where I will measure the load at 90-degree angle and the maximal load. And sorry about the focus, I noticed this only later, but at least we can see the numbers, which are in Newton meters. And after this test, a very similar deformation in both cases. The creep test, the deformation under the constant load, which will be 1.25 kilograms. And measuring the distance between two reference surfaces. The position is locked for more accurate measuring. And I measure them every day. This is now the 5th day. I already measured them. I'm removing the load. And very similar permanent deformation in both cases, maybe a little bit more on ABS part. And now the impact test with these notch test objects and a 0.5 kilogram hammer. ABS. 0 position. ASA. Oh. One more time in slow motion. Well, this is a problem because this brake friction will deform the results of the ASA. This is how they look like after this test. And I have a problem with this setup and tough materials because the hammer is chamfered. This is not a problem with brittle materials, they broke immediately and the part fly away. But tough material bends and we have this friction which deforms the test. But this is what I can currently do with my equipment. Actually, I already ordered an industrial impact testing machine and it will arrive in a month or something like that. So until that, I have no choice but use my equipment. Back to our test. This is the 0 position of the hammer and this is the edge position after breaking ABS and ASA parts. And of course, for the ASA part, the real brake load is smaller, but this is what I can measure, but I will write this warning in Excel tables. The temperature test in the oven. I want to record the temperature of the first deformation. M10 nut as a small load is placed on these test objects and I'm following the temperatures, and approximately at 83 and 90 degrees Celsius these test objects started with deformation. First I checked them with the spoon, but after only half minutes I could even touch them with my fingers, and for the feeling the ABS is softer compared to the ASA. It's time to analyze the results. This Excel table you can download from mytechfun.com website, but also the data will be uploaded to that summary table for my Patreon supporters. Here you can see the print settings. For the ABS I already mentioned that it is far above the recommended print temperature range. But anyway, let's start with the creep test. So these are directly measured values, but what you need is difference between 2 days, and that's what we can see on this graph. And we can see even on the 2nd day I could record some creeping. Only on 3rd day it was reduced, and the ASA was better in this case, but this is also very good, very low value. On a tensile test, all brake loads were very similar, and between these two they're almost equal, but this is a little bit lower compared to the average value from my summary table. On the layer adhesion test, this is very good. I mean, everything above 20 kilograms is very good for the ABS. On shear stress, again a little bit weaker compared to the other materials, but very similar between each others. On the 3-point bending test, this is the deformation after 30 seconds under these values. But this is more interesting. This is the deformation under these values after 1, 30 and 60 seconds. And here we can see that at the beginning on lower loads they are almost equal. And then on higher loads actually I could notice a little bit more deformation on ASA material. On torque or twist test, again they were very similar in both cases. On isolated impact test, I already mentioned that the ASA result is deformed because of that additional friction, but this is what I could measure and this data will be added to that summary table, but again with this notification. On a temperature test, well, the ASA performed a little bit better compared to the ABS, but a little bit lower compared to the average similar materials. Now some quick conclusions for the end. Well, if I have to choose between these two materials, I would definitely say that ASA is worth the price difference. I also checked these materials, compared them to other similar materials from my summary table, and I could see a little bit weaker tensile and shear stress of these materials, but on the other side better layer adhesion. Also again a little bit weaker temperature resistance, but better printability. So even on these very high flow rates, I had zero problems so far printing these filaments. About my future Bambulab filaments videos, I have polycarbonate in transparent and black color. So in one video we will see if the color has the effect to the polycarbonate filament strength. I hope you will follow me to that video too. Don't forget to click the notification bell button too, because in most cases, I'm not sure why, but the notification is not sent if I upload new video. I mean, I have 48,000 subscribers and only between 2,000 and 3,000 views, so I'm not sure why, but the video will be created, but it is not sure that you will get the notification about that. Well, anyway, I hope you will follow me to that video too. Thank you for watching and happy printing!